is that what?
So that means it becomes 4 times
Oh, 4 times.
Oh, yeah, cause 2 squares.
Yeah.
quadruples.
So 4 times the momentum?
No, 4 times the old kinetic energy.
Oh, 4 times the momentum.
That's 2 different questions on the test.
Oh. Well.
The 2 types of collisions. Remember those?
Oh yeah, we know them. We just did them Tuesday.
Elastic and inelastic. What's the difference between them?
One speed, one no.
Okay, which switch? These bounce apart.
And inelastic stick together.
Right. And elastic stick together. In free fall, what quantity increases with time? Velocity, yes. In free fall, what increases with time?
Put inelastic?
Velocity. Yeah, elastic bounce apart and elastic stick together.
Velocity.
But a free falling object, what increases is the velocity.
Free fall.
Yes.
Free fall.
Newton's first law is a statement of the law of
Say that again, the
Newton's
first law of the state.
is
An object in motion tends to stay in motion.
law of
inertia.
First law is inertia. The rate at which work is done is called what? How fast you want to work is called what?
Okay.
How fast you want to work. Power.
Oh,
Rate of doing work is power. Now, of course, this can be potential energy or kinetic energy. It doesn't just have to be work. The rate at which you change potential energy is power. The rate at which you produce kinetic energy is power. The rate you do something means dividing by time. That's the rate of anything.
So the test is next Thursday?
Sir,
When's the
Yes.
test?
Next
Next
Thursday.
Thursday.
love to have it Tuesday, but then we wouldn't get to do lab. Unless you want to do lab Thursday.
We can do lab Thursday.
Mm-mm.
No, the test over with, we're reviewing it now, you're giving us the answers, we write a word for the word, right?
I don't have an off day until Tuesday, so no.
Will you still come? though,
They
don't
might
you?
be on Sunday.
Yeah, but I can't go to tutoring or anything like that.
Oh, you want to do tutoring before the test.
Right.
Okay, let's leave it like it is then. Newton's third law, the action-reaction forces, what can we say about them?
Newton's third law, what?
They're equal and opposite.
Every reaction has an equal but an opposite reaction.
That's part of it, but that's not what this question is.
So read the question again, what is it?
What can we say about Newton's third law of action-reaction? What can we say about the
Every
forces?
action there is an equal and opposite.
The forces are equal and opposite, but there's one other important detail we need to put in there.
About reaction. Reaction.
This force is the force of the moon on the earth, This is the force of the earth on the moon. Notice that they work on different bodies. And that's what I want you to remember
What
in
was
this
your
question.
question?
Work on different
Newton's
bodies.
third law,
Oh, his third, okay.
the forces act on different bodies.
Okay.
Equal and opposite, equal reaction forces. But they act on different bodies. They're the same in magnitude, but they act on different bodies and they're opposite in direction. What's the weakest fundamental force? Gravity. Yeah, there you go. What's the strongest fundamental force?
Strong nuclear.
The strong nuclear, right.
Weekend,
Weakest of the four fundamental forces is gravity.
gravity. The strongest is.
Padded dashboards in automobiles reduce injury how?
Say that again.
Absorb, absorb.
And actually, we could even enlarge that question. Padded dashboards, airbags, seat belts, all those reduce injury how?
About absorb or something.
It's all related to the impulse momentum relationship. Impulse. And this is change in momentum. When you have a collision, or when you jump up and down on a floor mat in gym, there's a certain amount of momentum that has to be absorbed. You can't get away from that. The only way you can help out here is to slow down your car. Don't drive as fast. So if you do have a wreck, it won't hurt as much. But once you've had your collision, or once you're having a collision, you've got a certain amount of momentum, and that momentum has got to be absorbed. So we can't change this, but we can change these. How?
Take the T out.
If you have a soft surface of any kind, floor mat, airbag, padded dash, seat belt, all of these increase the time it takes to stop, thus decreasing the amount of force that you feel. And it's the force that causes damage. Okay?
So to answer the question, the padded dashboard reduces injury how?
The amount of force.
The amount of forces.
The amount of force.
Well, they reduce, the answer on the answer says by increasing the stopping time.
By increasing?
Yeah, they reduce the force by increasing the stopping time. Work and energy have the same units. I think you all remember that.
Say that again.
Energy is the ability to do work, so work and energy are both measured in the same units, usually joules. The constant capital G. What's the significance of it? Well, first, where does it appear? Where do you find the capital G constant?
Gravity?
Law of gravity, right. Well, universal law of gravity is, as explained by Newton, is capital G times the product of two masses divided by the square of the distance between their centers. Capital G is a universal constant. Why? Because gravity works everywhere in the universe. We are being attracted right now by the furthest galaxy. Now, the force is not very great because of the great distance between us. But it's still there. It's measurable. Gravity is universal. It extends throughout the universe.
So you say universal, what constant?
Mhm.
Capital G is a universal constant. Compare the concepts mass and weight.
The larger the mass, the more it weighs?
Huh?
Larger the mass, the more it weighs? Maybe?
Mass is the quantity of matter, or how much stuff you got in you. And this is universal. That was one of your homework questions also. That means your mass is the same everywhere. I don't care if you're on Mount Everest, or you're in Death Valley, or you're on the moon, or you're on Venus, or you're in outer space. You still got the same amount of mass. That does not change. What's the weight then? Force of gravity.
So what determines how heavy something is?
Sir?
So what determines why something is that heavy? Like iron is obviously heavier than copper. So
Okay, that would be density. Density is how compact the mass is. On a molecular level, it really has to do with how many protons and neutrons it's got in the nucleus. But weight is a force of gravity, and it does vary with where you are. Whereas the mass is the same everywhere. Why do dishes remain on a table if the tablecloth under them is pulled rapidly?
Speed.
What law is that called?
Equal force, something.
Say that again?
the second law, but something won't happen without it.
Inertia.
Inertia.
I know you've seen magicians do it on TV. You've got a table full of dishes and you got a tablecloth, and the magician yanks it out real quick and the dishes just sit there. Now that only works if you do it fast, and the dishes and the tablecloth have to be very smooth.
Yeah, we tried it growing up at my grandmother's house.
Uh-oh.
We weren't allowed to smack over.
Did she use a willow switch?
No, no, we just, man. it
Oh,
was
I
like
got
a whole-
it.
It wasn't bad, it wasn't that bad. We only broke like 3 or 4 dishes.
We got the
And
pick
she
our
came
own
in and caught it,
pieces.
so we didn't try to get it.
When we pick our switches, I make sure
Sure it wasn't a skinny one, because boy, those.
Okay. Now, we've had several of these questions before, so I'll just mention them briefly. You've got an object dropping, and you know how high it's dropping, and you want to know its speed just before it hits the ground. So you've got height, and you want to know time to hit ground. Time to hit the ground. What you're using is actually, let's see, come on now, let me get it straight. You got your distance, you got, okay. You really could use, kinetic energy and potential energy. Is that gonna give us the time? No, that's not gonna give us the time. What do I want for time? T equals 1/2 AT squared. You solve that for T. You've got your acceleration is 9.80. And your time is what you're looking for, and your distance is the height the object drops. How far it drops. So if you wanna go ahead and solve it, it's, T equals square root of 2D over A. If you wanna solve it algebraically first. If you've got a person's weight on the earth and he's going to the moon, how much will he weigh? Assuming that the force of gravity is 1/6 that of the earth. How do you find his weight on the moon?
Oh, you said the force of gravity is?
On the moon, the force of gravity is 1/6 what it is on the earth. So if you want to find your weight on the moon, what do you do? Divide by 6.
Divided by 6?
Yeah. Car is climbing a mountain. Car has climbed a mountain. You know its mass, you know the height of the mountain, and you know how long it took it to climb the mountain. These are given. What you want to find is the power. Well, the power would be mgh over T. Now here we've got a race car going around a corner. Got a race car going around a curve. And the curve has a curvature so that its radius is given. You've got the speed. And the speed is constant, it's average speed. And you're given the force that's required to hold it into the curve. So you're given force. This is called centripetal force. And actually the unknown in this particular problem is the speed. So we've got centripetal force is mass times centripetal acceleration. But centripetal acceleration is v squared over r. And you've got the speed, you've got the radius, and you've got the mass. So everything's given except v, and you can solve for v. There's a couple of bonus questions. I'll go over.
How you gonna do
Can you
that?
give us a hint on what it will be about?
Well, one of them involves nuclear fusion, like Star Wars.
Okay. That helps. I'm still writing it down, Bonnie, I'm still looking up.
Is it in our book?
Okay. Well, I've gone over